Welcome to Learn Robotics and AI, where I teach you robotics, computer vision, and machine learning to help you become a self-taught robotics software engineer. And in this video, I'll be giving you a list of top 10 ROS projects for absolute beginners. That's right, you do not need any prerequisites in order to start doing these projects. So first of all, I'll be talking about how you can start learning ROS, what is the best way to start learning ROS, and then I'll be giving you the details of 10 specific projects. The first one being simple publisher subscriber, which is followed by turtle sim navigation, and the third project is then that of implementing object detection in ROS. That is followed by a path planning project. The fifth project deals with simultaneous localization and mapping. And the sixth project involves teleoperation control of a robot using ROS. The seventh project involves learning and dealing with sensor fusion. And the eighth project involves controlling a manipulator arm. This is followed by voice control and automated docking. So these are 10 projects that I would be talking about in this video. So stay tuned for that. But first, how to learn ROS? What is the best way to learn ROS? I have talked about this many times before, that the best way to learn ROS is by actually building projects, and a lot of experts in ROS, everyone basically talks about this. So you probably know that the best way to learn ROS or any tool essentially in the domains of robotics and AI is to take up projects, and I'll be giving you a step-by-step process, a project based system on how you should be learning ROS. So first is of course installation of ROS. If you haven't installed ROS, go ahead and do that. Second is to get familiar with the fundamentals. If you're an absolute beginner and you have no clue what ROS actually is, get familiar with the fundamentals, and I'll be talking about how to do that in a bit. And once you are sufficiently confident about the fundamentals of ROS and you are satisfied with your understanding of the fundamentals, you can immediately start building a mini project. And once you do that, you would inevitably be encountered with certain bottlenecks or roadblocks that prevent you from completing the project. And that is where you would need to revisit the literature, uh, get hold of the fundamentals again, refer to the resources in ROS that would allow you to really fill in the missing pieces in your knowledge. So these could be related to just the ROS framework or robotics theoretical concepts that you are not familiar about. So installation, there are a lot of ROS versions out there, and for ROS 1 the recommended version is ROS Noetic. This is the latest one, and for ROS 2 the recommended versions are Iron Irvine and Humble Hawksbeak. So these are the two recommended version, and the industry and academia are slowly switching to ROS 2. So I would recommend that in order to get started, you can just, if you have that opportunity to choose between ROS 1 and ROS 2, choose ROS 2, because everyone would switch to ROS 2 sooner or later. But the ROS version Iron Irvine is reaching its end of life in November 2024. So if you choose to install ROS 2, go ahead and choose Humble Hawksbeak. And ROS 1 in its entirety is reaching its end of life by May 2025. So this has already been planned. So ROS 1 would lose its support altogether, and that is why I recommend that you install and stick with ROS 2, and that to Humble Hawksbeak. At least this is the version that is the latest and that has long-term support for now. So stick with ROS 2 Humble Hawksbeak. Install this, and once you have installed this, you need to get familiar with the fundamentals of ROS. What are the different components of ROS? ROS nodes, topics, services, actions, publishers, subscribers, and a lot of different components. You need to get familiar with this terminology, and the way to do that is you can watch my video titled The Complete List of ROS 2 Resources. And these consist of tutorials, YouTube videos, websites, articles, all of the different resources that you can find related to ROS 2, and essentially these should help you get familiar with these fundamental concepts and choose any resource that you resonate with and that you find interesting to study with. So once you get familiar with these fundamental concepts, go ahead and start building the project, and I would be sharing a list of projects in this video. So this is a step-by-step system. So go ahead and watch my previous video, understand the fundamentals after you've installed ROS, and start playing with it, get familiar with nodes, services, and all of the fundamental concepts. And then uh, use this video to start building ROS projects. Choose a project that you find interesting, and once you do that, you would be inevitably encountered with certain roadblocks, and that is where you just have to use this website called Robotics Stack Exchange. And this is essentially a question and answer server. It's essentially Stack Overflow for robotics. So you can ask questions. You can also view responses by other people who probably have had issues, debugging problems related to ROS, robotics, and so on. So this is the entire system. It's simple. It's not really that complicated. And if you follow that, this is actually very simple to learn ROS. So let's go ahead and now talk about the first project, Simple Publisher Subscriber. So Simple Publisher Subscriber, this is the simplest project that would allow you to gain a foundational understanding of the ROS concept. So you can even go ahead and start with this project if you want to skip viewing the other resources to get familiar with the fundamentals. Although I do recommend that you spend some time looking at those resources and getting familiar with the fundamentals. But this is a Simple Publisher Subscriber project, and the goal would be to create a simple publisher and subscriber using ROS. That is it. It is that simple. And the tools that you would be using is you can choose any programming language such as C++ or Python, so one of these. And you can and of course we are working with ROS here. So if you are very new to programming, I would say you can stick with Python. If you have a certain level of programming background, and if you want to essentially work as a robotic software engineer, you can go ahead and switch to C++ or start with C++ for this project. So the fundamental concepts that you can learn by means of doing this project are essentially these simple topics, these simple concepts called topics, nodes, publishers, subscribers, and messages. And the difficulty level is essentially very basic, so I would give it 1 star. And this is a resource that you can essentially refer to if you get stuck trying to build a simple publisher and subscriber. But the way that you should be approaching this building this project is that you spend some time. For instance, let me go back to this slide here again. So the way is to get familiar with the fundamentals first by looking at the resources that I mentioned in this video, and then after that, don't look at the resources that I'm sharing in these projects. Look at these resources only after you get stuck. So the goal is to gain familiarity of the concepts and just start doing this project all by yourself. And so this is a simple subscriber publisher tutorial that you can essentially follow. There's also a nice video underlying it. So this is project number 1, and this is the overall idea. You have nodes, and then you have a topic. A publisher node publishes a message to a topic, and then a subscriber subscribes to this topic and receives the message. So that is it. This is this simple idea. And now let's move on to the next project, which is Turtle Sim Navigation. So this is another very simple project, and the goal is to navigate a turtle in a 2D environment using ROS. So that is it. and you use ROS and Turtle Sim, of course. And the concepts that you can learn by means of doing this project is brush up your ROS basics. You get familiarity with 2D navigation, what is odometry, pose, all of these fundamental concepts. So this is also very basic project, so I would give it 2 star. And these are some of the resources that you can refer to. Turtle Sim Cleaner, so this is a GitHub repository with all of the link to the tutorials, and you can essentially follow this tutorial, although it is an older one, but this is something that should be sufficient for you to get started. You can look at some other recent tutorials on this website, and essentially just follow this link. So Turtle Sim Navigator, this is essentially how the project outcome would look like. You can define any goals of the project, and you're free and flexible to define how you want to navigate. Do you want the turtle bot to essentially move towards a goal? Do you want it to um, follow a certain path? You can define your goal more specifically, but essentially the problem statement is to navigate a turtle bot in a 2D environment using ROS. Once you do that, you would have a sufficient level of understanding to now implement object detection using ROS. Detect objects using a simulated robot in Gazebo. You would get exposure to Gazebo now, so we'll be introducing a new tool here, which is a simulation environment called Gazebo. The concepts that you would learn by means of doing this project are sensors. You'd get familiarity about sensors, object detection, and YOLO. Difficulty level is slightly harder than the previous one, but it's still a very simple project. You can follow these resources. YOLO object detection. So this specific
Atera
YouTube
ist das IT-Wundermittel.
video by the Construct, and the Construct is essentially a very good channel if you want to follow for ROS. It has a bunch of ROS tutorials, and this is something that you can follow. And then there is the Z ROS examples repository by Stereo Labs. If you have access to the Z camera, then this is something that you can follow. If you have some other camera, you can just follow general object detection libraries and stick with that. Adding object detection in RAW. So this is another one by Stereo Labs. This is a nice tutorial, and you need not have a camera. You can essentially just work with images, or in a simulated environment, publish images to a topic and simulate object detection as well in a way. Or you can use your uh, webcam essentially, or your phone camera. I'm not specifically limiting you to any hardware. You are free to work in a simulated environment, or if you have access to a camera, then it's of course very good. So object detection, this is how it might look like. Depends on the objects that you have at your disposal, depends on whether or not you have a camera and things like that. So moving on to the next project, what was the next project? The next project is essentially now dealing with path planning, and the goal is to implement path planning algorithms for a mobile robot. And all of these projects, let me point to you, is they are designed to be working in simulation. If you have a certain level of, if you have some hardware with you, then of course that is very nice, but you do not need to. Everything can be learned in a simulation environment, so you don't have to spend any extra money, because these robotics components are very, very expensive, and you do not have to, especially as a beginner. Just try to gain that expertise, and try to get access to the hardware by working in a company which essentially work with hardware. You can apply for internships or part-time roles, or develop your skills to such a level that you can essentially get a job in these companies and then get exposure to hardware. So ROS and RWIS, so a new tool called RWIS, can be learned in this project. You would learn about several path planning algorithms such as RRTs, and um, navigation stack, cost map. So these are the concepts that you would learn, and this difficulty level is also simple, 2-star project. And you can follow these resources: global path planner, ROS plugin, very nice, organized tutorial. All of these tutorials are most of these tutorials you can follow from ROS wiki, wiki.ros.org. It has a bunch of tutorials. So ROS navigation in 5 weeks, this is a nice video series that you can follow. And again, I would like to point out that you should try to build this project all by yourself and only refer to these resources when you get stuck. Path planning basics, again, a nice video tutorial by the construct, which implements Dijkstra's algorithm. And the next one is path planning by Husarian Doc. So uh, these are some resources that you can refer to. So this is how the project would look like depending on which environment you choose and so on. So uh, essentially creating a plan and navigating through an environment. Now moving on to the next project. The next project deals with SLAM. This is something that is very commonly used in mobile robots. And the goal is to create a 2D map of an environment using SLAM. If you have access to a camera, or even using your mobile phone, you can essentially try to create a map of your room. That is a fun mini project that you can do that would get you exposure to implementing SLAM, simultaneous localization and mapping. And you can do that using gmapping package in ROS. And you can implement Hector SLAM. You get exposure to laser scan, LiDAR, mapping and localization, Hector SLAM, all of these concepts. Difficulty level is 3 in this case, and you can follow these tutorials: indoor map using ROS and LiDAR on the website Automatic Edison. So this is a nice article that follows that you can follow to implement SLAM. The next one is ROS G mapping website on this YouTube channel Robometrics. So this is something that you can look at, and this is how the project would look like. So it would you would essentially navigate through an environment, and you would be able to create a map of the surroundings. So this is how it looks like, and the agenda would be, and the next project would then be of teleoperation, how you can control a robot using keyboard or joystick. You do not need to have a joystick. You can essentially teleoperate a robot using your keyboard, and control a robot using keyboard or joystick inputs is the problem statement. You would use the teleop package, and you get understanding of what teleoperation actually is and how human robot interaction works. Also a simpler project of 2-star difficulty, and you can follow these resources: teleoperation ROS wiki. So again, a really good resource on ROS wiki, and you can essentially then go ahead and follow the links in this to see the modules and the packages used for teleoperation. And you can also follow the subsequent tutorials once you are done with teleoperation. Essentially, this is a very simple project. Turtlebot teleoperation, another one on ROS wiki, which you can follow. And then there's joystick tutorials if you are working with joysticks. So for some reason, this link takes forever to load, but you can essentially follow these links on the website. I'll talk about where you can essentially get a list of these resources and the links and all of these projects on my website. I'll be sharing this after I am done talking about these projects at the end of this video. So this is something that you can expect to do by means of teleoperation. Of course, here this is an interface by Freedom Robotics, where they have essentially made a GUI, and this is something that one can control using mouse, and this would essentially be able to navigate a robot. You don't have to make a GUI like this. You can essentially teleoperate using just keyboard controls, WSAD, or the arrow keys. Or if you have a joystick, you can follow the joystick tutorials on the ROS Wiki website and follow those. And coming to the next project now, the next project is about sensor fusion, and you need to combine data for from multiple sensors for better accuracy. You need to have multiple sensors in this case. You can have simulated sensors in ROS and Gazebo, so that shouldn't be a problem. You would be you would learn concepts such as sensor fusion, data integration, localization, extended Kalman filters. Don't worry if you don't know about these terms. That is the goal. While you start doing these projects, you would be able to learn these fundamentals as you start building these. So learning by doing. This is a slightly harder project with 3-star difficulty, but it's still a beginner friendly project. So you can follow this, and you can follow this ROS sensor fusion tutorial on the website. There's also nice YouTube video. Of course, this is 4 to 5 years old, but you can still follow it, and you can even refer to other GitHub repositories which implement sensor fusion in ROS. Then there is this ETH ZASL sensor fusion. There's a list of these tutorials that you can follow. And of course, these resources are not comprehensive. This is just to give an idea of what the kind of resources for each of these projects would look like. Um, you can essentially spend more time and you'll be able to find tons and tons of resources. There's no shortage of resources, so I didn't spend a lot of time listing 10 to 20 different resources for each of these projects. You'll be able to Google that easily. And this is essentially how it might look like depending on which sensors you use. Are you using lidars? Are you using camera or GPS? What are you using? So it depends on the sensors, but this is essentially the ROS terminal, and this is what you can expect the project outcome to look like. So now coming to the next project, which is arm manipulation, control a robot arm to pick and place objects. Very interesting project. You can use the Move It library. You would be introduced to the Move It library here. You can learn concepts such as manipulation, kinematics, control, grasping, planning. Difficulty level is 3 in this case, and you can refer to these two resources or Google for more similar resources. So here is a YouTube video, um, ROS manipulation on a real robot arm. You do not need to have a real robot. ROS wiki arm manipulation. So all of these resources here would be sufficient. And I forgot to replace the arm manipulation GIF here, but you get the idea. It is, you can imagine a 6 degree of freedom robot manipulator arm here, trying to pick and place objects. And then voice control a robot using voice commands, and you can use ROS, Google Speech API, and TTS Watson as packages, and you would be able to learn concepts such as speech recognition, natural language processing, and controlling a robot. Difficulty level is also 3, and you can follow these resources. ROS tutorial voice. So this is GitHub repository that you can refer to or find similar repositories um, of that nature. And the next one is from Husarian Docs, and this is also a nice resource with detailed tutorials and explanations. So this one is about controlling a robot using voice commands. So coming back to this GitHub repository, so there's also a YouTube video demonstrating it, and you can define the objectives of your project. You can take help from the description here. And this is probably something that you can expect. You would be giving voice commands, and you would be saying, hey robot, go to this particular goal or come here, and things like that. You can do this in simulation again. You do not need an actual robot. So moving on to the next and the last project, that is of automated docking, and you need to program a robot to return to a docking station autonomously, and you would be using tools such as ROS and navigation stack. You would be able to learn concepts such as automation, docking, infrared emitters and receivers, and the difficulty level is also 2. In this case, and this is a nice resource on ROS Wiki with a lot of even theoretical explanations on how docking station works, like what are the sensors involved, how are the messages received and emitted using the infrared sensors. And you can also follow this GitHub repository called Autodoc, and they have a nice explanation with a full state machine and architecture diagram and examples on how to run it with a mock robot. So these are a list of resources. This is what how docking looks like for those of you who are not familiar with the term docking. Automated docking using ROS, using infrared sensors. So that is it. This was the video explaining 10 different ROS related projects that you can start building as a beginner without any prerequisites. And lastly, I would like to share with you where you can actually find a list of these tutorials. So go ahead and click on the website learnroboticsinai.com, and then you can select, hold on, it's still loading. Yes, then you can go to blog, and blogs are essentially at the bottom. So these are compilations of a lot of my LinkedIn posts that were well received and that you found most helpful. And there's this latest article or blog called ROS Projects for Beginners, and you can just simply click on this, and you would be essentially given details, description, what are the tools, concepts, difficulty level, and also to links to the resources for each of these projects. So by the way, this is the raw arm manipulation GIF. I forgot to replace it in the presentation, but it's there in this article. So you can follow these resources, and you can also follow this guide called Comprehensive List of ROS2 Resources. So you see this is a long article with just a lot of clickable links, and this is everything, all of the resources, all of the popular ROS2 resources that you can follow. A very, very comprehensive list. All right. So that is it. I hope you find this video helpful, and if you did, make sure to subscribe to this channel, because this channel is now going to be dedicated to creating content such as providing you with resources, roadmaps, even project breakdowns, and building projects that would allow you to become a professional robotics software engineer in different domains: perception, manipulation, using natural language processing for robotics, but essentially focusing on robotics software engineering.